Hello, it's dumplet here. Here's an item on algebra. So it's an item on floor functions. So find all possible values of x to the following equation. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. As with a lot of the questions on the channel, we start with some small observations. So the first thing that I think many of you would immediately realize is that the two numbers inside the two floor functions, they are reciprocals. So let's just say one of them was u, then the other is going to be 1 over u. Now the next thing to realize is that both of them are positive, because, well, x squared plus 1, that's obviously positive, and then 10, that's just positive. So positive numbers everywhere. So it is expected that these two numbers are going to be positive. So we're taking the floors of two positive numbers, and apparently it's equal to 1. Now just one more thing to realize is that, well, since it's u and 1 over u, well, for example, if u was greater than or equal to 1, then 1 over u, it's going to be less than or equal to 1. It makes sense because you're taking the reciprocal. So, and obviously on the other hand, if u was less than or equal to 1, 1 over u would be greater than or equal to 1. So with this, we can try to just kind of list down all possible combinations for the values of these two floor functions. Because now that we know that reciprocals and they're both positive, we can try to assign values. Now obviously none of these two can be 2 because, well, if any of these two are 2, the other must be negative. Well, it's impossible because these two values are positive. So if this was 1, then the other must be 0. And on the other hand, if this was 0, this must be 1. And that's going to be pretty much it for the possible arrangements or distributions of the values to these two floor functions. Because of the fact that they're positive and because of the fact that they add up to 1. So these two are the only possible distributions. So what remains for us to do is just to kind of consider case 1 and 2. Let's focus on the top case first, so case 1. Case 1 being the first term being equal to 1, the second term being equal to 0. And as with a lot of questions on the floor function, we're going to kind of use the fact that, okay, since the floor of x squared minus 1, x squared plus 1 over 10, it's 1, we know that the value must be greater than or equal to 1, but less than 2. Now, next, the floor of 10 over x squared minus 1 being 0, we technically don't have to consider it being greater or equal to 0 since we know it's going to be true because, well, as we've mentioned, it's already a positive. So I'm just going to say it's going to be less than 1. And the intersection of these two, so these two, well, in effect, these two are now rational. These two are inequalities now. So the intersection of these two inequalities will be the solution for case 1. All right, so let's try to get the values of x. So we can multiply both sides by 10 here. 10 would be less than or equal to x squared plus 1, and then less than 10. Less than 20. And then we can subtract both sides by 1, so 9 less than x squared less than 19. Now, we know that x squared should be greater than or equal to 9 and less than 19. So let's consider the positive one first because it's just x squared. So if I consider just the positive values of x, that's going to give me obviously values of x from 3 to square root of 19. So x must be greater than or equal to 3 and x must be less than square root of 19. Now for negative values, it's going to look similar to this one, but just negative counterparts. So, well, x must be greater than negative square root of 19, and it's going to be less than or equal to negative 3. So these two are the solutions to the first one. Now for the next one, well, 10 over x squared plus 1 being less than 1, we just have to kind of consider, make sure that 10 over x squared plus 1, so make sure that x squared plus 1, the denominator, is just greater than the numerator. That's one way to think of it. So we can kind of write this down as, all right, we want the denominator to be greater than the numerator. And that's going to give me x squared being greater than 9. Now if I try to solve for x here, I'll get the possible values of x as follows. So again, focusing on the positive ones, I will get x must be greater than 3, and then on the negative ones, x must be less than negative 3. Alright, now if I try to combine these two, these are technically four different inequalities, but take note that the union of these two came from the first one, and then these two came from the second one. If I combine them up, let me write this in terms of interval notation, so it's going to be a little bit clear. So this one, it's going to be 3, and then square root of 19, so like this. And then this one over here would be negative square root of 19 to 3, like this. So the solution to the first inequality would be the union of, oops, it should be negative, so the union of these two. And then for the second one, it's just x greater than 3 and x less than 3. That's going to be simply equal to, well, this is going to be the values less than 3, and then this would be the values greater than 3. And if I combine these two, so I'll take the intersection of these two, I'll be getting the following. So the common solution would be from negative square root of 19 to negative 3, exclusive of negative 3, union with exclusive of 3, and then to positive square root of 19. Now you guys can realize here that, well, I could have made my life a little bit easier by focusing on these two, the two red underlined inequalities, and notice that if I combine these two, in effect, I'll just solve for x in the following inequality. Now we know x squared is greater than 9, and x squared is greater or equal to 9, but less than 19, so combining these two would give me this. And solving for this would actually immediately give us the solution that we have here. So that's another way to kind of take a look at this. All right, so that's for the first case. We have this value for this range of values for x. Now for the second case, we're going to do something similar. So for case 2, we want the floor of x squared minus 1 over 10 to be 0. So again, technically we can write the greater than or equal to 0 case, but we know that's always true because it's positive. So we just focus on this being less than 1. And then here it's going to be similar to the first one, greater than or equal to 1, then less than 2. Alright, so from the first one, I'll be getting the following. So again, with the similar reasoning, I want the denominator of 10 here to be greater than the numerator. So x squared plus 1 is less than 10. So in effect, x squared plus 1 is less than 9. So we're going to leave this as like this for now. For this one, let's try to view this. Let's try to multiply both sides by x squared plus 1. Now, multiplying both sides by a certain number in inequalities is technically a bad thing to do, but in this case, we are sure of the sign of x squared plus 1. We know that it's positive because it is x squared plus 1. So we can safely multiply all the terms here by x squared plus 1, and I'll be getting x squared plus 1 is less than or equal to 10, less than 2 times x squared plus 1, so 2x squared plus 2. Now, let's try to focus on the first two and the last two. The first two, it's going to give me x squared plus 1 less than or equal to 10, so x squared is less than or equal to 9. And then in the second part here, so 2x squared plus 2 is greater than 10, so that's just going to give me greater than 8 here. So 2x squared is greater than 8, which is going to give me x squared greater than 4. Now if I combine these two, because these came from the same inequality, I'll be getting 4 less than x squared and then less than or equal to 9. Now we can use the technique here. We can just combine these two first before solving for x. So x squared less than 9 and the 4 less than x squared less than or equal to 9. Combining them, we're going to get 4 less than x squared less than 9. And here we can easily get the solutions here because we know that if I focus on the positive values, it's just going to be values between 2 and 3. If I focus on the negative values, it's just going to be values from negative 3 to negative 2. So this will be the solution to case 2. So now that we have the solution for case 1, we have the solution for case 2. Just simply combine them, and here we have it. We have the range of possible values of x. these two came from case 1, and then these two came from case 2. We just take the union of both because those two are independent cases. And there we have it. We have x being any value between -19 and -3, or -3 and -2, or values between 2 and 3, or values between 3 and square root of 19. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!